Hello students, this is the 15th part of functions. Today also I am going to explain some problems based on domains and ranges, because this is a difficult concept in functions, finding domains and ranges, especially range. So here some basic functions are given, their domains and range are listed now, just observe. Okay. So first one is mod x. Domain is all real numbers, range is closed 0 to infinity. Step x, domain is all real numbers, range is only integers. Logarithm of x to the base a, provided a greater than 0 and a not equal to 1. So for this domain is 0 to infinity, logarithms are defined only for positive real numbers, output is all real numbers. Root x, domain is 0 to infinity, output is closed 0 to infinity. Sin x, domain is r, range is minus 1 to 1. So cos x, domain is r, range is minus 1 to 1. Tan x is, this is the domain already explained in trigonometry, and range is capital R. Cot x domain is this, range is this. Secant x domain is this, range is this. Cosecant domain is this, range is this. And a power x, exponential function. So domain is all real numbers, range is closed, open 0 to infinity, provided a greater than 0. These are some basic functions, important functions. Okay students. So inverse trigonometric functions are not yet started. After completion of that, I will explain what the domain and range of inverse trigonometrical functions. Okay. So today I am going to explain some problems based on JEE Means Model Problem Set 4. Some of them already explained in previous parts. I don't want again explain those problems. First problem already explained. Second problem also explained. This is the answer. Third problem also explained. Fourth also explained. Okay. So fifth onwards I want to explain here. See students, f of x is given as step x into sine of pi by step of x plus 1, integral part of x plus 1. Now we want to find its domain. Step x is defined for all real numbers. No? Put any x, it is defined. Sin x also, actually sin x is also defined for all real numbers. But instead of x, what do you have? Pi by step of x plus 1. Some values of x, this may be 0, no? But those values of x, this is not defined, means sin function is not defined. Just we want to identify what values of x, pi by step x plus 1 equal to 0 are not defined. Okay, that is for the values of x step x plus 1 equal to 0, then f of x is not defined. It is not defined. Not defined means not a real number, that like that. Okay. So now we want to know what values of x this happens. Step x plus 1 equal to 0. What values of x? According to the property of step function, I can write this. It's already clearly explained. X plus m equal to step x plus m, where m is integer, then only you can write, otherwise you can't write. Okay, don't think that step of x plus y equal to step x plus step y, wrong. Only for second part is integer. So step x should be equal to minus 1. What values of x this happens? No, I will show you. Take x equal to here, this value true, this value true, this value true, minus 1 also true. These x values you can take. You can't take 0. 0 minus you can take. 1 minus 1 you can take, minus 1 plus also you can take. If x belongs to closed minus 1 to open 0, then step of x plus 1 equal to 0. What is the meaning of that? To find domain from all real numbers, you want to remove these real numbers. Okay, now you want to write domain of f of x. Domain of f is from all real numbers, minus 1 and 0. This should remove. Minus 1 should remove. That's why what happened? Minus infinity, minus 1 open, union, 0 not there. No, we can't remove. That means 0 should be in a domain to infinity. This is the domain of f, fifth problem. So I want to search for answer. So according to my answer, I can say 2 is correct. Okay. Yeah, listen students. Next, this one already explained. Okay. I don't want to waste my time. Seventh one I want to explain. Yeah, logarithms are involved, no? Should take care of that. F of x equal to square root of logarithm of 5x minus x square by 4 to the base 10. Okay. One more log is there, sorry. 2 logs are there. Okay. No, only one log. Correct only. What I wrote correct. Okay. So, what are the conditions I will write down first of all. Logarithm of 5x minus x square by 4 to the base 10 should be greater than or equal to 0. First condition. What is the second condition? Logarithms are defined only for positive real numbers. This is second condition. Now you want to find their intersection. That is the domain of the function. So first one, can I write 5x minus x square by 4 base 10 greater than or equal to logarithm of 1 base 10. So log x base a greater than log y base a. Directly I can say x greater than y if your a greater than 1. Obviously 10 is greater than 1 only. Directly what I can write now? 5x minus x square by 4 is greater than or equal to 1. Or 5x minus x square by 4 minus 1 greater than or equal to 0. Or 5x minus x square minus 4 by 4 greater than or equal to 0. All the denominator 4 greater than 0, it is enough to find value of x which gives denominator is greater than 0. Means 5x minus x square minus 4 greater than or equal to 0. I don't like minus in front of x square. I want multiply minus another side. X square minus 5x plus 4 lesser than or equal to 0. Or x minus 4 into x minus 1 lesser than or equal to 0. So what is the meaning of this? 1, 4 plus minus plus negative symbols. Means x should be between 1 to 4. That says first condition. So I will write here first condition. Implies I will write implies x belongs to closed 1 to closed 4. Yeah, this is one part, not total. Now by using second part we need to solve. After that we need to find their intersection. Second part, what second part saying that 5x minus x square by 4 greater than 0. All the denominator greater than 0. Numerator must should greater than 0. 5x minus x square greater than 0. Or x square minus 5x less than 0. Because I don't like a negative symbol in front of x square. Okay, x of x minus 5 lesser than 0. You know how to find a solution for this by using Weyerhaeuser method. Plus, minus, plus. So all these values, open circle, open 5. Second one gives what nana here? X belongs to open 0 to open 5. Now I want to find their intersection. Students listen, interesting one. 0 open, yeah, 5 open, 4, 1 closed, 4 closed. So what second one saying that your x should be in between these two. What first one saying your x should be in between this. So intersection is this one. You know? Therefore, x belongs to closed 1 to 4 is the domain of the given function. Okay, so I can go with option 1. Yeah, student. Next, 8th problem. Find the domain of f of x equal to 2 logarithms are there. Should take care now. Root over logarithm of x to the base 0.2. First of all, for example, assume this k. Log k should be greater than 0. Already root over is there. No? Root over means a positive only. Except the values of x which gives this 0, that should subtract. That's all. Log 1, x is can't take as 1 here. If x is taken as 1, log 1 base 0.2, 0, log 0 not defined. That's why x should not be equal to 1. X should not be equal to 1. We'll see later what happened. Okay, and what's condition? What second condition? Inner function should be greater than 0. Log x base 0.2 should be greater than 0. And your x should be greater than 0. Logarithm is there, no, inside. Under these conditions you want to find x nano. Easy problem only. Logarithm of x by 0.2 can be written as log 1 by 0.2 I can write here. Both are same, no? So x less than 1. Inequality will alter, x less than 1. So x equal to 1 also including, no? That's x less than 1 is correct. Correct, these two I can say x less than 1. So from this what you get? X greater than 0. Combined of these two or intersection of these two is the solution. So take number line 0, 1, open 0, open 1. This one saying that your x should be greater than 0. This one says your x should be less than 1. Intersection is this. Therefore, x belongs to open 0 to open 1. This is the domain of the function. Open 0 to open 1. This is the answer. Okay, next ninth problem. A is the set of real values of x such that e power 1 by x minus 1 lesser than 1. Then what is A? Means domain. Domain should find. Easy problem. E power 1 by x minus 1 lesser than e power 0 I can write. E power x lesser than e power, directly you can say that x less than y because e is a number which is greater than 1. That is 2 point something. So 1 by x minus 1 less than 0 I can say, or 1 minus x by x less than 0. To apply sign scheme or Weyukar method, I don't like negative symbols in front of variables. X minus 1 by x is greater than 0. Just I multiplied minus. Now I want to use Weyukar method. 0, 1, plus, minus, plus. Yeah, only open circles this all. Okay. So plus symbols you want. Plus symbols means what is the meaning of that? Your x belongs to minus infinity to 0, union 1 to infinity. Where is that? Option 1 is correct. Yeah, okay students. Next, the problem inverse trigonometry. Not yet started, no. After completion of that I will explain this problem. Okay, Nana. 11th problem, the domain of this something. Easy problem only. Yeah, f of x is equal to logarithm of something minus cubed root, not square root. Take care. This is different for all real numbers. Important thing, student. Important thing. This is different for all real number. Cubed root, no. Cubed root of negative number also real number only. Square root of negative means not real number. So this is different for all real number. Just we want to find what values of x this should define, means inside bracket should be greater than 0 because logarithms are defined only for positive real numbers. X minus 5 by x square minus 10x plus 24 should be greater than 0. That's all. X minus 1 by x minus 6 into x minus 4, that one greater than 0. Number line 4, 5, 6 all are opens. Plus minus, you want positive symbols. What I can say, Nana? X belongs to open 4 to open 5, union open 6 to infinity. This is the domain of the function. Open 5, okay. I will go with option 3. Next 12th problem, Nana. Yeah, interesting one. F of x is given as 1 by logarithm of, that is, okay, mod x only, no problem. Okay. See here, actually logarithms are defined only for positive real numbers. Already mod is given here, no problem. So defined for all real x except some values of x which this is gives 0 or undefined. So what is the meaning of that? If you take x equal 1, then what happens? 1 by log 1, 0. 1 by 0 not defined. If x is taken as minus 1 also not defined. 0 also not defined. Log 0 not defined. Except these three values, everything you can take instead of x. That's why domain of f is all real numbers except these three. Minus 1, 1, 0. Okay. Yeah, I can go with option 1. Next. Students, next problem, 13th problem. F of x equal to cubed root of x. Clearly, I already explained. whatever be x, this is defined, into cot x. Just you want to find the values of x which gives cot x defined. Already you know that cot x means so cos x by sin x. If sin x equals 0, cot x won't define. Or already you know cot x domain. That's the domain of the total function. Domain of cot x is domain of f. Understood? So what is the domain of cot x? You know that domain of cot x is all real numbers except the angles of the form n pi, x equal to n pi, where n belongs to z. So this is the domain of cot x, that only the domain of the function. Where is that? Where is that? Second option. Okay, now 14th problem. 14th problem. Yeah, where is that? Here. Okay. So f of x equal to root over logarithm of 1 by mod sin x. Students, important note, while finding domains of any functions, don't simplify the function. For example, log x square base 10 given. Don't write this in the this as log x base 10 and don't find the domain of this. That is not correct. Don't disturb the nature of the structure of the function. Don't disturb the structure of the function. Taking that function as it is, you want to find the domain. Okay, because these two are different. See, actually in law of logarithm, these two are same, but domain sense they are different. I can say these two are different functions. So instead of x, anything you can write except 0. Here what should take? Instead of x, you want to take only positive real number. See, observe, these two are not same. Okay, don't apply law of logarithms while finding domains, or any operations you can't apply in functions while finding domains. Yeah, first what is the condition? Root over should be greater than or equal to 0. This should be greater than or equal to 0. First condition. What second condition? Your mod sin x is not equal to 0. Two conditions. Two conditions. Okay. So first condition I want to solve logarithm of 1 by mod sin x greater than or equal to logarithm of 1 to the base 10. For example, this is 10, that is 10. So 1 by mod sin x greater than or equal to 1, or 1 minus mod sin x by mod sin x is greater than or equal to 0. Just I took LCM and everything completed. So already you know that mod sin x, sorry, I will write mod sin x value is closer to 0 to closer to 1 only. What is the meaning of that? Take any value of mod x here, your value is 1 or lesser than 1 only. That's why this valid, only one value of x you need to take, that is mod sin x equal to 0. That value should find, that should be removed from all real numbers. Okay. Okay, students. Just what values of x? Mod sin x equal 0. Indirectly, what values of x? Sin equal 0. That is sin x equal to 0. What value sin x equal 0? X equal n pi. X equal n pi, where n belongs to z. Means what is the meaning of that? From all real numbers, you want to remove these real numbers. So domain of f is all real numbers minus n pi. Actually, what should write Nana? All real numbers x such that x equal n pi, where n belongs to z. Where is that? Here, option 3. 14th option 3. Yeah, 15th. Easy problem only. Just this should be greater than or equal to 0. R equal to 0. X square minus 4 mod x plus 3 greater than or equal to 0. Or to solve this type of problems, if modulus involved, so x square and mod x square both are same none. That's why instead of this I can write mod x whole square minus 4 mod x plus 3 greater than or equal to 0, or k square minus 4k plus 3 greater than or equal to 0. So what I did here, k is taken as mod x for my convenience. This is k minus 3 into k minus 1 greater than or equal to 0 by using number line 1, 3 plus minus plus you want positive symbols. What is the meaning of that? Your k should be less than 1 or k should be greater than r. So k means what? Mod x. Mod x lesser than 1 or mod x greater than or equal to 3. Just we want to solve these two now. I want write here. What you got I will write here. Mod x lesser than or equal to 1 or mod x greater than or equal to 3. So already in basic mathematics I explained clearly, this is nothing but minus 1 lesser than or x lesser than or equal to 1 or x greater than or equal to 3 or x lesser than or equal to minus 3. Now I want to use number line, here minus 3, here 3, here minus 1, here 1. What first one saying that your x value should be this, second one saying that your x less. R is there, R not end, R. So final domain I can say, domain of f is minus into minus 3, minus 3, minus 3 closed, okay. Union closed minus 1 to 1, closed 3 to infinity. This is the domain of the f. So where is that? Option 4. Okay students. Yeah, next problem. Yeah, f of x is equal to root over 1 by mod cos x. Simple problem. So 1 by mod cos x should be greater than or equal to 0. Okay, this is always greater than or equal to 0 except the values of x cos x equal to 0. Those values should be subtracted from all real numbers. Cos x equal to 0, then f is not defined. What value cos x equal to 0? X equal to n 2n plus 1 into pi by 2. For these values of x, cos x equal to 0. So these values should be subtracted from all real numbers. Therefore, domain of f is all real numbers x such that x equal to 2n plus 1 into pi by 2, where n belongs to z. I will go with third. Yeah, students, next advanced type problems. So first problem is multi-correct answer type. This total one more than one type. F of x is given as here 1 by 1 plus x square. Yeah, you want to find domain and range, both should find. Clearly it's showing that domain is all real numbers. Any x it is defined, that's why. Or y equal to 1 plus x square. For every x belongs to R, gives y also belongs to R. Therefore, domain of f is all real numbers. Domain I can choose first option. This is a multi-type, no? That's why we need to find range also. 1 plus x square equal to 1 by y, or x square equal to 1 by y minus 1, or x square equal to 1 minus y by y, or x equal to root over 1 minus y by y. Y becomes real number, or sorry, x should be real number, means that 1 minus y by y should be greater than or equal to 0, or y minus 1 by y should be lesser than or equal to 0. So 0, 1, plus, minus, plus. So this. What happened? Open 0 to closed 1. This is the range of the function. So y belongs to open 0 to closed 1. Okay, no problem. Observe here. So y should be positive only, no? So what you got? Positive only, 0 to 1, correct only. So what I can say, range of the function is open 0 to closed 1. Yeah, I can go with 3 also. That's why our answer for the first problem is 1 and 3. Yeah, in the second problem, f of x equal to sin x plus cos x. First of all, I want domain of f. Simple function of all real numbers, because domain of sin function all real number, domain of cos function all real number, interaction of all real numbers, domain is all real numbers. Okay, now we want to find range. Y equal to sin x plus cos x. Already we know one thing in trigonometry, that is, if a function given a cos theta plus b sin theta plus c given, its mini value equal to c minus root over a square plus b square, maxi value equal to c plus root over a square plus b square, means the value of this expression is lies between these two, including this and including this. Like that, here a means 1 and c 0 only. So what I can say, mini I can write, I will write. I will write here, 1 minute, y equal to cos x plus sin x plus 0. So mini equal to 0 minus root over 1 plus 1, that is equal minus root 2. Maxi equal to c plus root over 1 square plus a square plus b square, that is 1 square plus 1 square, that is root 2. So range equal to closed minus root 2 to closed root 2. Okay, this range is this. Domain is all real numbers. Again 1 and 3 answer for the problem number 2. This is a important model, very important problem. Okay, the domain of f of x is minus 1 comma 2. Domain of f of x is minus 1 comma 2. What it means? X lies between minus 1 to 1, like that. So then domain of f of sin x, interesting. Domain of f of x is minus 1 to 2. Now we want to find domain of f of sin x means what value of x, what values of x. Sin x belongs to open minus 1 to 2. This is the meaning, none. Okay, just what values of x, sin x lies between minus 1 to 2. That means minus 1 lesser than sin x less than 2. Such x value and find. So using inverse trigonometric functions you can find out, but you people don't know its inverse trigonometric functions. That's why I want use graph for this, nana. Graphically also can say the answer. This is sine graph. Yeah, this is y. No, your y value should be lies between minus 1 to 2. Your y value should be minus 1 to 2, somewhere here 2. What are such x values? What are such x values? Actually, I can't say all real numbers. Here given all real numbers. I can't say all real numbers. All real numbers for any x you take, sin x value is minus 1 to 1, including minus 1 and 1. You are including land, r equal to not there. That's why I can't say that a minus infinity is the domain of this function. That's why first option is wrong. Students, listen here. What values of x, sin x lies between minus 1 to 2. For example, what values of x, sin x lies between minus 1 and 1 means I can say that all real numbers. But what is there? R equal to not there, here. That's why I can't say that I can't take all real numbers. Some values of x, sin x also minus 1 only. So if you take domain is all real numbers, some values of x equals sin x or minus 1, but you don't want a sin x as minus 1 here. That's why I can say that the domain of the function is not a minus infinity, something not minus infinity. That's why I can neglect this. Is the answer for that problem. Next problem. Okay. Domain of f of x is open minus 1 to 2. Domain of f of sin x means log x, not sin x, log x, sin x completed. F of log x mean we need to find x so that minus 1 less than log x less than 2. Okay. So simple one, no? Minus 1 less than log x base e less than 2. Or applying log on other side with the base e, minus 1 into log what I can write, wait. So instead of 1 I can write logarithm of e power minus 1 base e, both are same, observe, less than logarithm of x base e less than logarithm of e square base e I can write. See, observe, correct only, no? What the meaning of that? E means what? The number which is greater than 1, inequality won't alter. E power minus 1 less than x less than e square. What the meaning of that? X should be belongs to 1 by e to e square. So this is the domain of this function. This function. See, clearly coincide, no? Clearly coincide. That's why I can move with the second. Okay. So this is multi-type, no? That's when you need to check remaining also. Remaining things also we need to check. Remaining options also we need to check. This is obviously not correct. So maybe 3, I don't know, I want to find. Okay. Domain of f is minus 1 to 2. Domain of f of step x mean we need to find x so that step x should be belongs to open minus 1 to 2. Minus 1 less than step x less than 2, such x value I want to find. So step x should be greater than minus 1 and step x should be less than minus 2. Okay. So first of all I will take this is as a 1 and this is a 2. Separately I will find, student. This is interesting problem. Yeah, first of all step x is greater than minus 1. I will show you by using number line. This is minus 1, this is minus 2, this is 0, this is 1, so on. If you take instead of x 0.1, 0.1 step 0 only, 0 greater than minus 1 true only, I can take all these values. 1 also I can take, all these values I can take. So if you take this value minus 0 point something, minus 0 point something step is greater than minus 1, step of minus 0 point minus 1, minus greater than minus 1, wrong. Means what happened? These values you can't take. 0 you can take, but less than 0 you can't take. That's what I can say. 1 gives x belongs to closed 0 to infinity. Closed 0 to infinity. That is important. Okay. So I will write here 1 gives, x belongs to closed 0 to infinity. So what second gives should find now. After that their intersection gives the solution. End is there now here. End. Step x is lesser than 2. Number line 2 minus 1 0 minus 1. Less than 2. What should take instead of x? Less than 2. I can't take 2 no here. I can't take 2. If you take 2, 2 less than 2. 2.1 I can't take. 2.1 also I can't take. 1.1 I can take. No, 1 point something I can take. 1 point something 1 only. No. So these values I can take. These values I can take. 2 I can't take. That's why what says that x belongs to minus infinity to open to. I will write that. Second one gives x belongs to minus infinity to open minus 2. Their intersection should find now. So I want to use number line to find the intersection. Okay, students, open to and closed 0. First one saying that your your x value should be 0 and more. This intersection is this. So x belongs to closed 0 to open to. This is the domain of this function. But here what is given? Domain open 0 is given. That is interesting. Open 0 is given. Should get closed 0. That's why I can't take this is the answer for the problem. So only one correct answer, that is 2.